So pretty much we're going to do the same thing we have been doing. In that step 1, we're going to simplify. And in simplify, we're going to remove what? Right. Remove parentheses and combine terms. And then we're going to isolate on one side or the other, whatever is easiest, right? So, in example 1, is there anything to simplify? I don't think so, right? So let's make a decision. We want to isolate the A on the left or the right? You want to get it on the right? What side do you want the A to end up on? The left. Okay, good call. And so one reason that you can use is whatever side there are more of the A's, that'd be a good side to put it on. It will avoid a lot of negative signs. So if I want it on the left, in this case, where don't I want it? On the right. How do I get rid of the A on the right? Subtract A. So on the left, what do I have? 2A minus 6. So I would, first of all, start isolating the variable. Then I move the numbers. Here's the A. I want to get rid of the 2 or the negative 6. Which one should I attack first? How? Add 6, add 6. And so who's left on the left side? 2A. What do I have on the right side? 10. Almost done. Who do I want by itself? A. Who do I want to get rid of? How are the 2 attached? How do I undo multiplication? Divide. And so A is 5. In 2, we can simplify first. Hint, hint. Left-hand side is what? Okay, 21. What? 20. Oh, 20. My bad. 20 what? Minus 7x. On the right side, I also have like terms. They don't cancel. Negative 6 what? Plus 21. Okay? From there, you try to do this on your own. I'll be with you in a moment. Now, how many of you ended up with the x on the left? How many of you ended up with x on the right? Okay. I would recommend the right, but I'm going to go with the majority and see what happens. It doesn't matter, but you just have to be careful. So we're going to say that we're going to have the x end up on the left, which means in this case we don't want it on the right. How do I get rid of negative 6x? Add 6x to both sides. What's negative 7x plus 6x? Negative x. And who's here still? 20. On the right side, negative 6x and positive 6x is 0x, or just 0. Plus 21 is? Plus 21. What side is the x on now? Left. So where do you want the numbers? Right. How do I get rid of this positive 20? Subtract 20. Subtract 20. Who's left on the left? Be careful. Negative x. Good. What is 21 minus 20? 1. Now, it looks like for many of you, you're done. But I want x by itself. That is not x. What is it? Negative x. So at this point, you have two choices. Classically, what students have done is they divide both sides by -1. I would rather multiply both sides by -1. In all cases, all we're doing is the same thing to both sides, because conceptually, the idea of an equation is to keep this thing balanced. So it's a negative times a negative. Positive, 1 times x. Right-hand side, a negative times a positive. Negative, 1 times 1, 1. If you ended up with the x on the right side, did you still get -1?
Yeah.
Okay, you should have, unless you made a mistake. I don't know. Because they were both even. What a lousy reason. And my approach has always been, make it small. Don't do the whole thing at once. So, the product, what does that mean? You're going to multiply two things. And who are the two things you're multiplying? 7 and 6. What does the word is translate to? And real tough, what does 42 translate to? 42. Or Jackie Robinson's number. So, twice the sum. Stop. Just translate that. 2 times plus. There's a problem there. That's going to be 2 times only the first number. What you guys said out there was good. Parentheses. 2 times the sum. Now I have to add the numbers before I take twice of them, right? Or double them. Twice, and the sum of who?
3 plus 5.
3 plus 5. Do you see that if the parentheses were not there, I would not be multiplying 2 times the addition answer. I would only be multiplying the 2 times the 3, but not the 5. This is real tough. Is equal to. Translation? equals, and 16. Okay? Translation. It's going to be a way, not the only way, but a way to get good at word problems. Okay? Because I am not here to just say, well, word problems are hard and you suck, so too bad. Okay? I'm here to try to get you started. Right? The quotient. There's that word again. What's going on? Division. And in this class, division is going to be a fraction bar. I know, there's this dot with a line. Now, I saw this on someone's quiz, and I didn't take off because I don't know how this is done in other countries. But is it true that 2 dots without a line is division someplace else? No, serious, it could be.
Yes.
Is it?
Mm-hmm. It is.
Yeah? Where? Can I ask?
Yeah.
Okay. Could be because it's like, have, what is this? The ratio 3 to 4, right? So they could be saying it's a ratio 3 to 4, and that's still the same idea. Ratio, division, fraction bar. Oh, I get it now. I understand. I just have to be accepting of different things. But let's try not to use this as division very often anymore if we can help it, and use the fraction bar. But I get it. So the quotient of who?
45.
Negative 45 and 5. Now, could I put the 5 on top and the negative 45 on the bottom? No. Quotient and difference. What operation is difference? Subtraction. Quotient and difference, order is hugely important. So if this comes first and this comes second, the first number has to go on top and the second has to go on the bottom. Yields equals, guess what? As it turns out, you can see that this is a true statement, but that's just a natural consequence. I want to see you taking the words and understanding them and translating them to this other language called algebra or mathematics.